Good evening, students. Welcome to Shruti Academy. So let us start with the integration proving of the another special function. The function is integration of 1 upon under root x square minus a square dx. So this is also yet another special function. The integration of this function is typical, but the solution is written over here. It is log x plus under root x square plus a square plus c. Okay, so the integration can be only achieved by some trick, and the trick is the special substitution. The substitution should be kept in mind that we should substitute the value of x to be a sec theta. When we will be substituting the value of x to be a sec theta, then only we can do such type of integration. Okay, so let us start proving it that the integration of 1 upon under root x square minus a square dx is equal to log x plus under root x square minus a square plus c, and c is the integration constant. Okay, so we need to prove integration of dx upon x square minus a square, and that is in under root, okay, to be equal to log of mod x plus under root x square minus a square plus c. Okay, so we need to prove this integration. Okay, so the trick we already know. We'll be substituting x is equals to a sec theta. So taking LHS, and we will be proving it to be equal to RHS. Okay, so let us substitute it. So it will be dx upon under root a square sec square theta minus a square. Okay, so this dx will be also substituted to d theta. So let us see how it is substituted. So x is equals to a sec theta. Okay, x is equals to a sec theta. So differentiating it both sides with respect to theta, okay, so here it will be theta. So here it will become dx over d theta, and here we are differentiating with respect to theta. So sec theta, the differentiation of sec theta is sec theta tan theta. So it will be a sec theta tan theta. Okay, so this d theta I can take that side. So dx can be substituted as a sec theta tan theta d theta. Okay, so this is our substitution. So in the place of dx, it should come a sec theta tan theta. So our integration becomes now integration of a sec theta tan theta upon under root a square sec square theta. A square can be taken common, minus 1 d theta. So a square is in the square root, so it can come out from here. So it will become a sec theta tan theta upon A under root sec square theta minus 1. Sec square theta minus 1. Sec square theta minus 1 is tan square theta with the property 1 plus tan square x is equal to sec square x. So when we apply this property, sec square x minus 1 will be tan square x. So tan square x, so it is in the square root, tan square. When it will come out from the square root, it will be tan theta. Okay, so here I am getting A sec theta tan theta d theta upon, so here I will be getting A tan theta. A and A gets cancelled, tan theta gets cancelled. So here I am left with only sec theta d theta. Sec theta d theta. Okay, so now I have to integrate sec theta d theta. Okay, so integration of sec theta d theta is equal to log of sec theta tan theta. Second integration of sec x dx is sec x plus tan x plus c. Okay, so here the expression is in terms of theta right now. I need to resubstitute my values in the terms of x, because the question was in the terms of x, or the derivation which we were doing was in the terms of x. Okay, so from here I can take I can find out sec theta to be equal to x upon a. Okay, so I'm writing over here sec theta will be equal to x upon a, and this tan theta I can write as under root sec square theta minus 1. I can write in this form itself. So let us write first of all in this form. So it will be log sec theta plus under root sec square theta minus 1 plus c. Okay, so now in the place of sec theta I can easily substitute x upon a. Okay, so it will be log x upon a plus under root x square upon a square minus 1. Okay, when taking the LCM I can get over here log x upon a plus under root x square minus a square upon a plus c. Okay, so now when I will be taking the LCM of a, I will be getting over here log x plus under root x square minus a square upon a. Okay, upon a plus c. Okay, so this can be written as log x Yes, this can be written as log x plus under root x square minus a square minus log a plus c. Log a upon b can be easily written as log a minus log b. Okay, so it will be log log x plus under root x square minus a square, okay, square minus a square minus log a plus c. So these are the constants, minus log a plus c. Log a is a constant, it will definitely come some constant value. So this all together we can write it with the integration constant to be c1 or some c dash. Okay, so you can substitute it c dash or c1. So we will be getting log x mod of x plus under root x square minus a square plus c dash, where c dash is equal to I'm writing over here, c dash is equal to c minus log a. Okay, c dash is equal to c minus log a. So from here it is clear that it is equal to RHS, or here c dash you can do plus c dash, or you can do other way also. Here you can put the constant to be c dash, and then you can say c is equals to c dash minus log a. Okay, this will be all constant, so it will be integration constant. So c dash will be equal to c minus log a. So it is clear from here. Okay, so it is equal to RHS. So in this manner we need to proceed such type of function, and we need to find out the integration of such type of questions. Okay, so the main trick over here was substituting x to be equal to a sec theta. Substituting it to be equal to a sec theta. When you will be substituting it, then only you will be getting all these terms, and the tan theta will be getting cancelled, and then integration of sec theta d theta is left. That would be easy, and we can easily put over here sec theta plus tan theta. So tan theta again to be replaced by under root sec square theta minus 1. Now here we have already substituted x is equals to a sec theta. So sec theta will be equal to x upon a over here. So it will be x upon a. After solving it, we will be getting expression log x plus under root x square minus a square upon a. So it will take the form of log a minus log b, where a is log x plus under root x square minus a square and b is log a. So log a is yet another constant. So log a can be added with the minus log a can be added with the constant, and so another constant we will be getting over there. That constant we can denote by c dash. Okay, so it is equal to RHS. So in the next video we will be proving the next special function, integration of the next special functions. Okay, so thank you. So please subscribe my channel, please share my videos, and if you have any doubt you can ask me in the comment section. Thank you.